Okay guys, now that you've completed your quiz, we're going to move on. This is lesson 5, and we're going back to talking about completing the square and finding zeros. So previously, we've talked about finding zeros of a quadratic function if they're in vertex or shifted form. We've learned how to solve a quadratic equation by using inverse operations if we can. We've learned how to solve a quadratic equation by finding zeros when we can factor it. And today we're going to look at the other possibilities. So we're going to first find the zeros in simplest radical form for this function here, using what we learned in the lesson right before the quiz, okay? So we set that equal to 0. So 2 times x minus 2 squared equals, nope, not equals, minus 36 equals 0. Okay, so what we're going to do is we're going to set this all up and solve for x using inverse operations here. So we have 2 times x minus 2 squared equals 36. Let's divide by 2. And we get x minus 2 squared equals 18. Now we have to get rid of this squared here. So you take the square root of both sides. I'm going to take it up here, okay? So I have x minus 2 equals the square root of 18, and I need to simplify this. So this is going to be x minus 2 equals the square root of 9 times the square root of 2, right? And now this becomes x minus 2 equals square root of 9 is plus or minus 3 rad 2. From here, what we're going to do is we're going to, you can break it up, but like I showed you at the end of the last lesson, you can add 2 to both sides here and have your answer in one nice little piece here. X equals 2 plus or minus 3 rad 2. And that would be the zeros. The two zeros would be 2 plus 3 rad 2 and 2 minus 3 rad 2. Now they want us to find the two zeros to the nearest tenth. So I'm going to separate them. 2 plus 3 rad 2. And then 2 minus 3 rad 2. And I'm going to use my calculator for this. Okay, so 2 plus 3 rad 2 equals 6.2. And then 2 minus 3 rad 2. Oops, I forgot to write rad 2 because Drew is dancing. So that's going to be 2 minus 3 rad 2, which is negative 2.2. Oh, you got a touchdown? Good job. 14, wow. Good job. So these are the two zeros to the nearest tenth, 6.2 and negative 2.2. Okay? All right. So of course, in order to find the zeros using inverse operations, we need our quadratic in the form a times x minus h squared plus k. So there were a few examples that we saw where we were able to solve, okay? But if we want to be able to find zeros, it has to be in this vertex form. So we learned back in the last unit how to complete the square in order to get our functions into vertex form. So we're going to show how we can do this. So first we're going to show how we would do it by factoring. Then we'll do it by completing the square. So we have this function, x squared minus 6x minus 16. So remember, when we're finding zeros, we're setting our function equal to 0. So you never want to forget that step. To factor, this is going to be a double bubble with x in x. Last term's negative, so it's a plus and a minus. Middle term tells me the bigger number is negative. So I'm thinking about negative 16, two numbers that are going to multiply to negative 16 and add to negative 6. That's going to be negative 8 and 2. Okay, so then we find our zeros. So this is going to be x plus 2 equals 0 and x minus 8 equals 0. So subtract 2. One of the zeros is negative 2. Add 8. And one of the zeros is 8. Okay, so the two zeros here would be negative 2 and 8. Or, of course, remember, like this. I'm just going to write or. Because I've seen quite a few of you using that notation on Google Classroom, so I'm going to try to remember to keep showing it. So now we're going to remember how we complete the square. So we could do this by putting it into vertex form to find the zeros instead. So how do we complete the square? So let me rewrite this. X squared minus 6x minus 16 equals 0. Middle term divided by 2. That gives me negative 3. Square it, gives me 9. We're adding and subtracting 9 here. So we're going to have x squared minus 6x plus 9. That's going to be my perfect square trinomial. Now I subtract the 9 to undo it, and then continue minus 16 equals 0. Okay, this turns into my perfect square, which I get from here. So it's going to be x minus 3 squared. Negative 9 minus 16 is negative 25 equals 0. And now I can use inverse operations to solve. So I add 25, and I got x minus 3 squared equals 25. Take the square root of both sides, and x minus 3 is going to be equal to plus or minus 5. So I'm going to break this up. Kind of running low on room here. So this is going to be x minus 3 equals 5, and x minus 3 equals, negative 5. Add 3 to both sides. X is equal to 8, and x is equal to negative 2. So we get the same zeros that we got over here. So now the whole idea here is, why would we need to do something way more complicated when I could have done it easily like this? The thing is, sometimes you can't factor easily, but you can put something into vertex form and then find the zeros. So you have to, it seems silly, I think he said, it seems redundant to know two methods, but you need to know two methods because sometimes you can't factor. So we're going to look at that here in exercise 3. So first thing we're going to do is we're going to do completing the square for this one now, okay? So we're going to get our x squared plus 6x plus 2 equals 0. We're going to complete the square. So we take my middle term 6, divide by 2, 3, square it, 9. So I take my x squared plus 6x. I'm adding my 9 here. That makes my trinomial. I subtract my 9 and bring down the rest. So this becomes x plus 3 squared. And then negative 9 plus 2 is going to give me negative 7. Okay? And now I can solve for x. So I add 7 to both sides. I get x plus 3 squared equals 7. Take the square root of both sides. Okay, I'm going to bring it over here. X plus 3 equals the square root of 7. Okay, and then this is going to be plus or minus, because I can't simplify that anymore. So to finish solving, I'm going to subtract the 3, and I have x is equal to negative 3 plus or minus the square root of 7. I can't simplify that 7 anymore, so that would be my 2 zeros. Now think about it. Before, when we did this, we got 2 rational numbers. We were able to factor, so that makes sense. Do you think that I'm going to be able to factor this if my answers are going to be irrational numbers? You're not going to be able to factor that. You can try all you want, but you're not going to be able to factor x squared plus 6x plus 2. No matter what you do, the double bubble will never work. There will never be 2 numbers that multiply together to 2 that also add up to 6. It's not going to happen because it's only 2 and 1. Okay? So they want us to show our guesses and checks. Really, the only options you have are x plus 2 and x plus 1, or x minus 2 and x minus 1. And no matter what, it's not going to work. This would be x squared plus 3x plus 2, and this one would be x squared minus 3x plus 2. So it's not going to work. Okay? So what can we conclude about zeros that are found using the zero product law? They're always going to be rational number. Okay? Zeros that can be found by factoring will always be rational. And it makes sense when you think about it. Because when you double bubble or use grouping or anything, no matter what, your answers are always, always, always rational. Okay? So that means if you can't factor it, I'm going to write this down here, okay? If a polynomial cannot be factored, which there are cases of those, we haven't seen them yet. If it can't be factored, it either has, you guess it, irrational zeros, or no zeros at all. It is possible to have no zeros. Okay, it is possible. So now we have a variety of tools at our disposal to find the zeros and turning points of quadratic functions. So in one case, we factored in the factored form of quadratic. In the second case, we have the vertex form of quadratic, and each one has its advantages and disadvantages. So for exercise 4, we're going to look at this function, quadratic, 2x squared minus 4x minus 16, and it's written in standard form. So first we're going to write it in vertex form, and then from there we'll state the coordinates of the turning point. So the first thing you should hopefully be thinking to yourself is that there's a GCF here. So before you go completing the square, you have to pull out that 2, remember? So I have 2, just going to rewrite it, 2x squared, minus 4x minus 16. You take the 2 out first, remember from the first 2 terms, x squared minus 2x, and you keep your minus 16 there. And now we go about completing the square. We take negative 2, dividing it by 2, that's negative 1, squaring that, positive 1. Okay, so we're going to add and subtract the 1, but remember, when you add it in here, what you're really doing is multiplying it by 2, so when you subtract it, you have to account for the 2, so 2 times 1, minus 16. Okay, this becomes 2 times x minus 1 squared, and that is negative 2 minus 16, that's negative 18. Now we're in vertex form, so the turning point is going to be opposite of what's in here, so that's positive 1, the same as this, negative 18. That's my turning point. So now, using this answer, we're going to find the zeros of the function. So I'm going to use the function that I found in vertex form, which was 2 times x minus 1 squared minus 18. In order to find the zeros, I set it equal to 0, and I solve. Going to add 18 to both sides. That gives me 2 times x minus 1 squared equals 18. Divide both sides by 2. X minus 1 squared equals 9. Now we're taking the square root of both sides so we can access that x. I'm going to bring it up here. That gives me x minus 1 is equal to plus or minus 3. Remember, square root of 9 is positive and negative 3. And now I'm going to split it up. I have x minus 1 equals 3 and x minus 1 equals negative 3. To find both possible answers, I solve both for x. X here is 4 and x here is negative 2. So my two zeros are 4 and -2. Okay, moving on. Determine the function's y-intercept. So if we need to find the y-intercept, remember the y-intercept is where, oh dear, x is 0. So you plug in 0 for the function. Okay, you want to go back to your standard form here. I'm going to find f of 0. So everywhere I see an x, I replace it with 0. So 2 times 0 squared minus 4 times 0 minus 16. So the y-intercept is -16, which you could have seen from here. Okay, that's how you would show it. Now they want us to draw a rough sketch. So we can draw a rough sketch because we have the turning point, and we know that it's a max or a min. Remember, if the first leading coefficient, if that number is positive is smiley face, right? So it's going to be a min. So I go to 1 approximately -18 down here, right? Let's just say that. Okay, and we also know the y-intercept is -16, so I know where approximately where it's going to touch the y-axis, and I also know the zeros, so I know where it's going to hit the x-axis. So 4 and -2. Okay, this is super approximate because I really didn't make that very accurate. So you can do a rough sketch like that. Okay, so this is 4, -2. They asked us to label the quantities. This is -16, and this is 1, -18. Ta-da! I hope yours is neater than mine. Okay. So now let's just, for our last final exercise, let's see if we can go in the opposite direction where we're able to look at the graph and get all of the information from the graph. So the quadratic function that's pictured in this graph has a leading coefficient that's equal to 1. And we're going to answer the following questions based on the previous work. So first we want to write the equation of this quadratic in vertex form. So in order to do that, we need the turning point, right? So let's identify the turning point is -1, -4. Okay, so the vertex or the turning point is -1, -4. They told us that the leading coefficient is 1, so we don't have to worry about that. So we can figure out that the turning point is going to be, remember, it's the opposite of what's here, so that's going to be x plus 1 squared, and this is the same, so -4. So that's going to be the equation in vertex form. Next, we're going to write the equation of the quadratic in factored form. So in order to do this, we are going to look for the zeros. Okay, so I have 1 0 at x equals 1. So one of them is in x equals 1, and then the other is 1 to -3. Okay, now remember, if those are the zeros, that means you would have had to solve this and gotten those as the answer. So this would be x minus 1, and this would be x plus 3. Okay, so this would be, I'm writing f of x, but you could also write y equals. Okay, this would be the factored form. Okay, I'm just getting all this information just from the graph, nothing else. Now, how could we establish that these were equivalent functions? Well, all we would have to do is write them both in standard form, and that's it. Okay, and to show this, I'm going to actually do it. We're going to multiply, expand, combine like terms, etc. So the first one, x plus 1 squared minus 4, that's x plus 1 times x plus 1 minus 4. So this is x squared plus x is 2x plus 1 minus 4. So this is x squared plus 2x, 1 minus 4 is minus 3. So let's see if when we multiply these, we get the same answer. X minus 1, x plus 3. Remember, if you guys like the box method, you can use that. FOIL is just faster for me, so I use that. X squared plus 3x minus 3x is 2x. Negative 1 times 3 is negative 3. So as you can see, they're equivalent. All right, and that's it, guys.